Dear viewers, now we will go for analysis and design. Now go to, before going to design, first we will run one this analysis for this structure. We will see if there is any warning or not. There it has got one isolated node. So to remove that one, go to edit, then select here undefined or any, click on all node, close, then delete only the selected so that river should not be deleted. Apply, yes. Now we can run the analysis. There should be no isolated node. So now this is okay. Now we will go for design, still design. Here we will define our member type properties. This one I'll rename it rafter. Here buckling length coefficient for rafter we will provide 1. Flexure of torsional buckling we will ignore this one. If we see the rafter configuration, here we can see this rafter top planes having the purlin joint connection, so that there will be a node to make it or to divide it in buckling length. There will be a small length generated for these nodes in top planes, and if there is stay angle with the purlin, so at bottom plane there will be also a small segment for this rafter length. So for this length, this buckling length coefficient for lateral buckling will be generated. So now here come to upper flange intermediate bracing. So we will provide here, we have modeled purlin here, so we will get two benefit from here. We will get purlin self weight here, and we will get this at points where adjoining elements are located. So by selecting this one, we will get these points where it should have the joint to create the segment for this lateral buckling length. So click on this. We can preview here how it is considering, like this here. For example, this is 18, this 12. For 12 number of bar or 18 number, we can preview. Go to here at points number 12. See here it is considering the joints where it is having the segment for connection or upper lateral joints. So this one, click on OK. For this upper flange, here we will get lower flange also at points, okay, and buckling Z we will go for same. So click on OK. Lower flange also we have defined at the same time. Here you can see here this is already marked like this. So this is done. Now for serviceability check, we will go to service. Here we will provide deflection limit. We will provide this limit as per our code recommendation. This one for live load, I'll keep this default value. You can change it as per your code requirement. And this one total 240. So click on OK. and save this one. For column, steel column, I'll go for same properties. Upper flange here, there is, if there is no side bracing, a side purling, so there will be no intermediate bracing. So I'll mark this one. If we don't unmark this one, this will not also have any effect because there is no adjoining joint. Okay, then click on OK. Then we will change only serviceability limit. I'll provide here 150 for total, 100 for column. Then click on OK, then save. Now for this bracing and strut, bracing or strut, all things will be okay. We will go for serviceability. We will not concerned about this serviceability. For bracing and strut, then click on OK, and then go for save option. Now this is bracing done and other nothing is balanced. So now close this one. We can see our display mark with color, section, material group, legend, member types by color. Here apply. We can see this is all our simple bar. Now we will change this. Go for rafter. Okay, yes, continue. Select similar by cross section. This one I'll apply as a rafter. Now for this one, select by cross section, click here, then apply. Now here also select by cross section, click here, apply. Now for column, S column, select this one, select this and select similar, click here, apply. And this side also select by cross section, click here, apply. Now for bracing and strut, select by cross section, click here, apply. And for the strut, select by cross section, then click here, apply. We will not assign any group or member type for purling because we have modeled this purling only for getting this purling weights and to get the adjoining joint to create lateral buckling length coefficient in the member type definition. Now we will go for group. Go to group, new, member list. Here name we will provide internal steel column. Okay, and here internal steel column, member list, we will go for list. Here I'll select the similar cross section, then this one, copy, paste here. Now here you can add more section to, if it is standard section, then we can provide our database sections to optimize the design. If there is any failure happens, it will choose the perfect section from here by optimizing design. As it is our user defined, so we will not get the sections. Here it is only for standard section. So click on save. Now go for new. Here we will go for SC, still column type 2. Okay, then now for here we will go for this, 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 sorry, press Ctrl, then select this one. So this 4 will be as int column, so as still column type 2. Click on save. Now go for new. Here we'll go for still column type 3 for the other, this one, select this, then here select this and this. So from here I'll copy this one, paste, and here still column type 3. So save this one. Now go for new one, delete this, we will go for selection, this in rafter cross section. Here will, it is coming automatically. Now after deleting this member list, now here we will go for rafter, main rafter 1, then click on save. Go for new one. Now this one, from here we will select this rafter, select similar, select this one, copy, paste here, done. Now this one will be main rafter type 2. Click OK, save. Now go for new one, now select this, and this one, these two, after type 3, or we can provide it in rafter ER1, then click on save, done. Now go for new one, these two, here delete. Now select this, select this one, then this one here 2. So now save this one. Now go for bracing, new bracing, here we'll delete this one. First we will select, then we will change the name, select by cross section, this one, copy, then here write bracing, save, new one, here delete. We will select this strut by cross section, then select this one, copy, paste, here we will write strut, then save. Done. Now we can see our group here. Number 1 internal steel column, number 2 steel column 2, 3, 4, 5, 6, 7 after 2, 8 bracing and 9 strut. Now we will go for code group design. Select this one. This is optimization option. If there is standard section we can provide, then we can click on this, then from here we can go for option. As we are not going for that one, we will go for this code group design, list code group, here all 1 to 9, close. This one we will go for ULS load combination from here to here 8 to 17. Now close 8 to 17. Now we will go for calculation. Click on calculation. Okay, in this bar for 1794 we have assigned such section type that it does not need lateral buckling analysis or lateral buckling verification, so no worry about this one. Main rafter we can go for this one. We can see here this is the this is the PMM ratio for steel column design 1.45, more than 1, so it is failing. That means in correct section we need to increase the section size. And here this bracing instability coming for this slenderness ratio more than maximum allowable 300. Here this is coming to us because this is 25 millimeter dia bar. Related to this length, it is slenderness is too much high. And for strut this is slenderness along Y direction, this is okay, but for Z direction this is little bit higher, that's why unstable. And here the design ratio also higher than the required, so this is 1.55 more than 1, so we need to change this section strut. And for bracing we can ignore this one as it is this is strut. For go to their bracing, here you can see this is the design ratio 0.78 less than 1. If we ignore this slenderness ratio for bracing, we can consider it as it is adequate. Okay, now we will go for strut change, and this section which is failing we will change the section. It is for column it is coming 1.84, so close this one, will not save this one. And for that member type, this one we have to, here we don't need to provide this one lateral buckling, that's why it was showing there one warning that it has not calculated or performed lateral buckling checking. So save this one. Now close this, go to structural model, Here we can go for section. We'll see this one. Here we will change the dimension. It's 312. For example, if we increase the flange thickness, we will see what happens. 1.4. Then add. I want to modify it because I don't want to assign again new. Although it is 12 here, I have provided 1.4. For our design purpose, we can change it, and if we add it, it will add here as another section. Then after selecting this existing section, we have to assign new section. I'm not going for that long procedure. For shortcut, I'm modifying this one, close, and this one rafter 95 to 40. This one also I am going for increasing flange thickness, and here you can provide 335 centi, 350. Add yes, and for column also for 350. Not this one, this SC, this one 335. Add yes. Now close, and another strut we need to change. For example, this one 175, make it 100, 150, and this 5 milli thickness. Add yes, close. This is strut section. I think we have made something wrong. This will be 10. Add yes, close. Then I will run the analysis. Finished. Now I will go for design. This calculation 1.22. For column, rafter reduced 1.18. So other things are okay. So in this way, by changing the section, we can reduce the ratio. Then we can finally get the design section. If we want to see map for all the members, can go for this member verification. Go to list. Here bracing this, bracing to strut. We will select, then close, then go for calculation. So after finishing, we can go for map. This one, this is our mapping. This is the ratio for steel members. So this main column and this rafter is failing. This section we can design after by increasing the section size. So in this way we can do modeling, analysis and design of portal frame in Autodesk Robot Structural Analysis. So thanks for watching. Stay tuned for more important tutorials.
Press the bell icon on the YouTube app and never miss another update.